little views of it. We do have a statistic from our sample that we just did today. We do have a statistic, yes? What's our statistic? Remember what our percentage was that we got? 41%, right? 41%. Let's not use all the data yet. Well, we're going to collate all the data here momentarily. But we got a 41%. But you have told me that you don't want to say 41% is the true parameter percentage, which I agree. I don't think you should either, for a whole bunch of reasons. So Ashton, what do we have to add and subtract to that 41%?
Probably all the data, like add all the percentages.
No. You just add, not even put it. You said something. I said, we're going to be off by A, and you said, so we need to have a percentage that we add and subtract from that 41%. Because we can't, saying 41% exactly is too precise. We want to be able to say it's between likely this and this. Does that make sense? We can't just say it's 41, exactly 41. If we tell somebody it's exactly 41%, that makes it seem like we spun all the pennies forever. We did.
49% out of all the humans?
But we didn't do all the humans. We only did 17 humans today.
41% of the population in this classroom.
Well, yeah, but that still means we're probably wrong. We're probably in error, and that's okay. So what we need to do is we need to come up with an error percentage. We're off, right? We're probably off, correct? So we need an error percentage. What should it be? Any ideas? What do you think? 5%? 6%? 8%? What do you think? What do you think? 1%? We off by 1? Any ideas? It's not an easy question. It's not an easy question at all. What do you think? What do you think, Nate? 2%. 2%? 2%? Cool. Anybody else? 20%. No, too high. 20% is too big.
Full range is only 15, so
Oh, so Yolanda said if you look at the full range of all the results I've ever gotten, it's 15%, so it shouldn't be more than that.
And interestingly, the one with the most is like smack dab in the middle of 7, and then Aaron on the other side of it.
I have a question for you, my dear friend. I love everything you just said. But here's the one thing. We did our sample independently of all the other results, right? So we probably shouldn't even look at those results to base our error estimate off of. Does that make sense? Yeah, so my question remains is what is the percentage we should be using? Well, believe it or not, there is a calculation. There is a calculation. And here is how you actually end up doing it. Your spins, we spun 170 times. Oops, turn my number lock on. You spin 170 times. We got 69 heads, correct? That means we got 41% heads. The margin of error is 7%. Uh-huh. Now some of you are shrinking your eyes and you're like, wait a minute, where'd that 7% come from? I'm going to tell you this right now, it's a calculation. It's something you calculate from your result. If anybody wants to see it at break, I'll show it to you. It's part of 243. I was very concerned when they put margin of error down into 105. I was concerned because I'm like, that's actually a 243 topic, you know? And they're like, yes, but 105 students need to know it. I'm like, so should we go through the calculation? No. Okay, you know that's going to piss them off, right? They're going to know where it came from. They're like, yes, but it's in 243. Yes. This is what happens when you let managers make educational decisions. They end up stepping on their own toes over and over again. So if anybody wants to see where that calculation, where that 7% comes from, I'm happy to show you a break. But it is determined to be 7% from the results we got. So, the margin of error, and I'm never going to have you calculate using the formula. I'm always going to give you the tool. I put one of these tools in Canvas for you to use. I'll show you before you go home today. The margin of error for our result is plus or minus 7%. So, we should not say, this is wrong, we should not say the percent of heads is 41%. We should not say that. Because that means that we spun all the pennies for infinity. That's the wrong way That's the wrong way to report our results. What's the right way to report our results? You say that again.
Plus or minus 41%.
Plus or minus 7%
Oh, that's
from the 41. So here's the more correct statistical way of saying it. We're confident that the percentage is between, we're confident that the percentage is between what and what?
34.48.
Yes. So what you do is, you have to do the math a little bit here. We have to add and subtract 7% from 41. That gives us two left and right bounds that we're confident it's in between. So, 41% minus 7% gives us, is that 34%? Is that correct? Did I do that right? 34%? Nope, forgot the 4. 34%. And then adding 7% would give us 48%. That is the right way to report on a sample. You never report your sample statistic and say that's what it is in the population, because you're probably wrong. You're probably wrong. So what you should do is get your statistic, then calculate the margin of error on that statistic, which I will either do for you or supply for you, one or the other. And your job in Math 105 is to take that and add and subtract the statistic and say, I'm confident it's in between those two. So Nathan, if you think about it, this actually kind of encapsulates what you said before. When I said, look at these results here, and what did you say? Do you remember what you said when I said, look at these results? You said they're all
Near 40.
They're all around 40%. Look what number is in between these two. It's in between there, isn't it? As a matter of fact, I gave you a visual here, and this is also in sheets. I'll bring this up after break. There's your confidence interval visually. I can go one better. Remember how all of you said at the beginning of the warm-up, you said it's 50% when you flip coin, when you spin coins, it'll be 50% just like flipping a coin. This is statistical evidence that it's actually less than 50%. Look where 50% is. Look where 50%. You see it up there, Ashton?
What kind of blurry, but yeah.
Yeah, 50. Oh, up, sorry.
You're good.
Sorry, no, I'll blow it up bigger. Hang on. Make it bigger. Yeah. See what 50% is? 50% is here. This entire interval is below 50%. That means even with the uncertainty of the plus or minus, it's still completely below 50%, which means it sure looks like coins are flipping at less than 50%. Now, Chance, you actually had, as far as I could tell, you had the reason earlier. Look at your penny. Take a look at your penny that I had you spinning. Look at the head side and look at the tail side. What do you notice about Lincoln's face on the head side versus the Lincoln Memorial on the tail side? It's subtle. There's more metal sticking out of the head side. You knew it, Allie! There's more metal sticking out of the head side than there is on the tail side. Which means when you start spinning the penny, this is my theory. I have no idea if this is true. This is what statisticians do. They do a sample, get a result, and then sit back and go, what could have caused that? This is fun. So my thought is, when you get the penny spinning, inertia takes over. An object in motion tends to stay in motion. An object with more mass has more inertia than an object with less mass. So the head side and the tail side are both spinning, but the tail side gives up first and lets the head side keep spinning and spin itself right down. Now, is it statistically significant? Well, here's what it has looked like over time, my dear friends. So this is a little bit hard to see. Let me zoom in a little bit. Okay, so this is the exact same results you just saw, except now I've added the confidence interval with the margins of error for each of the years that I've done it. So remember the 43% from the early people? I added subtract that margin of error. This is the 50% line right here, dear friends. That's the 50% line. You see how that early experiment crossed over 50%? That means I wouldn't be able to tell if there was a difference there. I couldn't tell if there was a difference in heads or tails with those early data. It was uncertain, statistically insignificant result. 50% is on the table. How about this next class in fall 2006? They got 39% heads. What do you notice about their confidence interval? It's below 50%, isn't it not? Is it not? Yes. Which means this class would have concluded we get heads at a lower rate than 50%. We get heads at a lower rate than flipping. How about this class? Did they get heads at a lower rate statistically than flipping? Yeah. Not these folks. These folks crossed. I know what some of you are thinking. You're like, yeah, but it only crossed way out here at the right. You're not allowed to say that! If it crosses, it crosses. It doesn't matter where. If it crosses, it crosses. Because you don't know where the truth. Here's the thing. On that margin of error that you added and subtracted 34 to 48%, you have no idea where it is in there. It might not even be in there. You might be wrong. It may have been something completely weird. And we probably didn't. We're going to talk about what that means later on. We probably did. You actually dealt with it a lot in your homework that you did. The 100-sided guide homework is actually directly tied to this. You're likely not wrong. You could be wrong. It might not be in there at all. But seeing this repeated over and over and over, Nathan, and seeing how they're all pretty close to 40%. But every once in a while, you'll notice that what happens to one of the classes? One of the classes gets a confidence interval that does what? They cross the 50% marker, right? So that class can't conclusively say that it's different than flipping a coin. But here's my favorite part about this. Here's y'all down here. There's y'all right there. Holy crap! Look at this one. What happened? Why is that one so wide in spring 24?
There's not much, and so it's a higher margin of error.
You say that. You say it again. Whoever just said that.
There's not many people, and so there's a higher margin of error.
Has anybody noticed a little correlation between how many spins there are and the width of the interval? The more spins, the tighter the intervals. The fewer spins, the wider the intervals. Why does that make sense? Logically, why does that make sense?
Getting closer to the parameter.
The more assuming you're doing good statistics, which we are, the more you do, the closer you should get to the parameter. As a matter of fact, take a look at this. Here, oh God, I'm zooming. I'm so sorry. I was trying to scroll up, not zoom. This is the confidence interval. If I put all of the data together. Remember I did the data earlier, it was 43.78%? That's the confidence interval for 13,000 spins. It almost doesn't look like an interval anymore, does it? It looks like a little tiny line. But it's not, it's plus or minus 1%. So with 13,000 results, you're off only by 1%. So I got a p-hat of 44%, plus or minus 1%. I'm confident it's between 43 and 45%. Which means I'm hella confident that it's below 50. So the moral is, if you're using a coin to decide between you and your roommate to take the trash out, don't flip it. Spin it and call heads. Tails! Spin it and call tails! Shit, I've said the wrong thing. Spin it and call tails! Because it looks like tails show up 56% of the time, or heads only show up 44%. Statistics, baby! How we feel? Feeling okay? Okay, you're all yawning and you're starting to fade. So let's take a walk. Let's go get some air, get some water. I'm gonna let this run because I don't feel like editing later. I apologies. So we get all of it. If anybody, did I just blink?
Yes,
Son of a. Okay. Okay. I'll let IT know they can watch my video, and at the hour mark, they can see the projector blink.
Yep.
Anybody want to see the formula? If anybody wants to see it, let me know.
Yes.
Do you want to see it, Kate? Katie wants to see it? Okay, perfect. Love it. It's going to be a little bit of, it's going to seem hand wavy, and I apologize. If anybody wants a justification for it, I can send you a video that I made for my stat students. I'll probably see the stats though, won't I? Yeah. You're pre-nursing, right?
Yeah.
You go for your bachelor's?
I I
Do you
don't know
think-
yet.
If you don't know your bachelor's, there's no reason to take stats.
Yeah, I'm thinking about
So, if there's any, oh, thank you. If there's any chance you might, I would say grab stats as soon as you can, just to get it under your belt.
Yeah.
I think it has a 5-year lifespan once you take it, before you take it again. I had a number of nursing students come back and take stats a second time because they're like, shit, I waited too long.
Yeah.
So, anyway. Oh,
Well, this is my first term back in college from 2012.
Oh, I'm so sorry to deal with me. Jesus. What a rude reentry. Just what all colleges like, this dude.
Pretty good.
This dude right here. Okay, so margin of error. All right. So the formula is a little bit of a bear. We'll bring it over here. Stone. Sorry, I kept you on camera there, Nat. I apologize. I'll zoom in a little bit.
Just want our homework, listen.
Just throw it, Paul. It's fine. I'll sort through it later. All right, so we're going to talk about something in this class starting actually Wednesday, most likely, called standard deviation. Have you ever heard of that phrase before? Elaine, you have?
Like a couple days ago.
A couple days ago, you experienced it. Awesome. Have you ever, Katie, standard deviation? Okay, don't worry about it. You know what an average is?
Yes.
Okay, you know what an average is. A standard deviation is just another average. So if I asked you what an average was, what would you tell me?
The amount you get when you add all the data together.
And then divide by, okay,
By the-
we're gonna come back to that on warm up on when. Involves lollipops, so then you're gonna like it. So it's a fun little activity where I don't let you use that formula, but I still want you to tell me what an average is, but we'll get to that.
Okay.
A standard deviation is an average, but it's not the average of the data. It's an average of all the differences from the data points to the average of the data points. So, that seems very strange, doesn't it? So let's suppose we were doing, get really quickly here. Number of words on the page in front of you. So let's say you've got 3 words, and Elena's got no words, 0, and Amelia's got like 16 words. Let's make life easy for ourselves. Let's call it 17 words. No, let's make it easy for ourselves. Make it 18 words. So Amelia's got 18 words. You've got 3 words. Elena has 0 words. On average, how many words do you have on your pages?
7.
Very nice. 7. Add them all up, divide by 3, 7. Okay. Standard deviation would say, okay, the average is 7, but how far away from that average are each of you? You're 4 away from that. You're 7 away from that. And you are 6 away from that. If I ignore the negative signs, just look at the distances away. So what did I just say? 4, 7, 6. Standard deviation would then add those 3 numbers up and divide by 3, and that's the standard deviation. On average, is how far you're off. Is that? I'm doing it really quick. We're going to come back to this on Wednesday. Elena, ask me that question.
Do they need to be like square them first?
No, I'm doing all that mentally in my head while I'm throwing them on the data sheets.
Oh, okay.
You subtract from the mean, square, and then take the square root later. It's a horribly confusing formula.
Yeah, I got it wrong yesterday.
Yeah, sorry. There's a much easier one to use called average deviation, which is almost the exact same thing, which is just look at the average, 7, and then literally just go the distances each data point is from the average, which effectively gets almost the exact same thing as a standard deviation. Don't worry. As soon as we start going down the formula rabbit hole, everybody starts hating statistics, and I'd rather you not. So the idea is there's something called a standard deviation in data sets. And that is fine, that's great. But if you're doing something like we're doing, which is you're drawing a sample and then trying to go to the population and say, okay, I got this number, I want to apply it to the population. Statisticians go, okay, now you need something called a standard error. Standard, don't write any stuff down. This is Math 240, Stats 243. A standard error is a standard deviation for a sampling distribution, which is words. That's a lot of words, ignore them. The formula for a standard error for this kind of data. Now here's where it gets interesting, and this is, Elena, one of the frustrating things about stats. Every statistic has its own standard error. So whether you have 1%, 1 average, 2 percentages, 2 averages, 3 percentages or more, 4 averages, 3 averages or more, everyone has a different standard error. For ours, the standard error is the square root of our percentage that we got in class today, which is 41%, then 100% minus that percentage, which would be the other 59%, divided by the sample size. So for us, the standard error is the square root of 41% times 59% divided by 170. Whatever that is. That's going to come out to about 3.5%-ish, somewhere in that neighborhood. Then the margin of error takes that, and based on something you're going to learn on, not Wednesday, I just lied to you, maybe next week. We take that and we use what's called a Z multiplier on the standard error, and this is depending on how confident you want to be. I'm hitting you with like 2 weeks of 243 right now in 30 seconds, so if it's feeling overwhelming, it should be.
Okay.
This is about 2 for 95% confidence. We're going to talk more about 95% confidence today. We can adjust that today. So that's how you calculate a standard. This is why I hide it in spreadsheets, because otherwise it's like, brr. And this is why I got frustrated with the state when they put margin of error down to 105. I'm like, you know that like, that's like a week and a half in stats class. Yes. Should I do a week and a half in 105? Oh no time for that. Okay, so you're asking them to just trust me when I give them the number. Yes. You ever taught math before? No. Been a manager for 30 years. Huh? It's not at all obvious. It's not at all obvious. So anyway, that's your 45-second introduction to standard error. Katie,
Excellent.
don't memorize it.
I know it all.
Yeah, you
Just-
do.
Yes,
You
I
do.
know.
Is it different for like what you do? Because I was using kind of similar to like line graphs where like a bunch of random dots.
That's regression.
Right, but like the one for social sciences and the one for like sciences, I guess, is different.
Well, that's only because they've chosen. Oh God! See, now we're doing. That's a rabbit hole right there. So I'll tell you. I'm going to address that with a story. Amelia Taylor, I've told you about before. She's the lady who took my prop stuff and got the job at OSU. Remember her? Yeah. She was amazing. And she used to ask me to come to the job interviews of the people that they hired after her. Because she's like, your bullshit detector's really good. And I need you to ask people questions when they try to bullshit us in the interviews. So this one guy, I forget his name, but I was in Cascades Hall when he gave his talk. He came in and he said something very similar. He said, well, for engineering, the p-values have to be very small, like 1%, but for social sciences, you can accept larger ones, like 5 or 10%. He's like, yes. I'm like, why? And he said, what do you mean, why?
That's what they accept, right?
I said, he's like, what do you mean, why? I'm like, why is it 10 times more stringent for engineering than social science? And he said, well, that's what they are. I'm like, yeah, but there's got to be a reason for that. You don't just do things because that's the way they've always been. That's how you get stale. And he couldn't answer the question, and nobody can answer it because it's arbitrary. Oh, you're getting into the nasty underbelly of research stats away. I encourage you to keep digging. Look at p-hacking, for
It's
example.
very interesting to take this math class and another one. Like,
Oh yeah, dude. Oh yeah. Especially because I'm not a statistician by training. I'm a mathematician by training. I fell into statistics 25 years ago because you ever gotten volunteered for something? When everybody's in a line and they go, who wants to do this? And everybody else steps back except you. Yeah, that was me 25 years ago. I fell into stats education because nobody else wanted to do it. And I'm like, Jesus, no idea. I do stuff. And I dug it. I'm like, this is awesome!
It's not statistics though, my math I'm doing is just math.
But you're doing standard deviations.
Yeah.
That's statistics.
I mean like the whole thing is statistics.
Oh, but you're doing statistics in your math class, which makes it even worse. Because guaranteed they're focusing on the formulas and not the meaning of the numbers you're getting. That's where statistics deviates from math. Statistics deviates from math. It's kind of like Portuguese and Spanish. They're both based in Latin. And you could probably understand a Portuguese speaker if you're a native Spanish speaker and vice versa, but there's enough difference there in context to be a different language. Italian. I mean, the obvious ones are like French and Italian. They're both rooted in Latin, but they're very, very different. They're very, very different interpretations of that Latin application. Stats and math is the same way. That's all I'm going to say. I don't want to say too much more. I won't say too much more. I appreciate you, though. Appreciate you. Now, here's the thing about margins of error. And I apologize, Katie, for that thing you had to watch about the calculation of standard error. And if anybody wants more, I have videos where I actually I derive all the formulas, and you can see the mathematical soundness of what's going on. And Elena, let me know if you want to see them. I can send them to you. They're better than this quick little hand-wavy thing. Like I've got like 12 and 13-minute videos where I derive these things. with care and editing, as opposed to just giving you a quick formula. I will show you in Canvas, I did put a margin of error calculator for you. Bring it over here. So if you're in your modules, in week 5, I gave you a little Mo visualizer. Let me get a copy here. And the way this works is pretty straightforward. Very often, I'm going to give you a margin of error, rather than have you calculate. This one that we just did right now, we didn't know what the margin was. I asked you, what should be the plus or minus? And you were guessing. You were like 2%, 1%, etc. It's determined by the study. But that's not the point of Math 105. The point of Math 105 is knowing that you have to use it. So in a lot of cases, I will tell you, so for example, our statistic was 41% and our margin was 7%. There's your confidence interval. 38%, or what is it, 34% up to 48%. So you can visualize what that interval looks like. Is that fair? More importantly, we'll do this today, is if you have more than one and you can compare intervals together side by side. That's where it gets more interesting. We'll come back to this. Okay. What I want to do now is I want to return to our PowerPoint, because now we've addressed the issue of our pennies, and we think our pennies are spinning at less than 50% heads, which I think is true. I believe we've already answered this question. Why does it make sense that the margin of error gets smaller as the sample gets larger? What was y'all's answer to this? I gave you a couple. If you only do a sample of size 10, you have to accept a 31% margin. I mean, that's crazy. 41% plus or minus 31%, that's ridiculous. Sample of size 100, it shrinks to 9.8%, 1,000, 3.1%, 10,000, 1%, 100,000, 0.3. Why does it make sense that they're getting smaller? I think you already answered this, didn't you?
It's more accurate as it gets closer to the parameters.
I love that. Can I change one word though? I'm not going to use the word accurate. I'm going to use the word precise. You get more precision. And here, this is a little bit maybe English versus math. You're already guaranteed accuracy. You're going to be quote unquote close to what you're looking for, Elena. But you're going to be closer, more precise, the more samples you draw. So the more you draw, as long as they're good samples, the more you draw, the better. And you can accept a smaller and smaller margin. This will keep shrinking down the further you go. Give me a thumbs up if that's kind of believable in the back of our mind. Like, okay, that makes sense. More data equals better data, as long as the data is quality data. I just used the word data 5 times in only 2 sentences. Woo! I'm getting paid. It's like, okay. All right, you badasses. Time to do some Googling. Whoops. Next. Okay, here we go. Record high in the U.S. put off medical care due to cost in 2022. Record high in the U.S. put off medical care due to cost in 2022. So the first thing I think of when I see that headline is, well, I circled it for you up there, the record high bit. Record high. What does that mean to y'all? Record high. What does that mean?
Probably the highest it's ever.
Say that again, Ashton.
The highest that it's ever been.
The highest it's ever been. The highest it's ever been. Maybe that's true. If that were true, what must they have done?
Taking samples from all over the years.
You say that again.
Taking samples from all over the years.
But if I may, if they drew samples from all those years, could they say it's a record high with 100% certainty?
No.
Because aren't their samples going to be uncertain a little bit?
Yes.
Yeah.
So the only way they could be confident to say that it is a record high in the U.S., they're even saying like the entire U.S., is if they did what, Allie? Oh, what were you going to say? You're going to say something.
Yeah, I was gonna say like they take the people that do go to the hospital.
Ah! Is that everybody? Because the problem with doing that is if you catch people that went to the hospital, right, what you just illustrated beautifully, by the way, is the problem with convenience sampling. Suppose they asked people that came to the hospital, did you have a hard time making this payment work? That's great, except for the fact that you're not getting people that didn't go to the hospital, which might be a more important data set, right? Thank you for that, that was wonderful. So what I'm fishing for here, and you're not even thinking about it, thank God, is the only way to make that statement that a record high in the US put off medical care is if they asked every single American. Did they? Probably not. Nobody asked me. Anybody ask you, Kristen? Nicole? Allie? So we didn't get asked. So that means this is not a what. If they didn't ask everybody, this is not a... That's a good answer. I wasn't fishing. Yes, it's not a parameter because they didn't do a... Thank you! They didn't do a census, so it can't be a parameter. Thank you. They didn't do... Everybody, on your phones or your computers, please find this study. Please. Thank you. Please find this study. I believe it's a Gallup poll by Megan Brennan. I'm going to find it too. I want to play. I can do this. Yes, I can. Good. Alright. Bye-bye, Ecola. You were fun to poke fun at. Hi. How's the name of that thing? U.S. put off medical care due to cost in... Alright. I think I found it. Megan Brennan. See, he looks very concerned. He does, doesn't he? He does. He's concerned. Oh, that just gave me an idea. My pencil. Here it is. You find it? All right. All right. So, we're going to keep this article up here. On the last page of your notes, I've given us some bullet points I want to kind of work through. So hopefully we found it. Found our Gallup poll. Let's find some of this stuff within the article. It's here. Actually, go nuts. Give it a shot. Take a few moments right now. Try to find the population Gallup is studying, the sample size they were able to get, the statistic in their sample. Just so you know, the statistic I'm fishing for here is this record high. That record high they're referencing, that's the statistic I want you to find the numerical value of. And then please, the margin of error, and then once you have the statistic and the margin of error, you can do like we did here and make the confidence interval. Give that a shot right now for a few moments, then we'll regroup. A lot of percentages in here. We'll deal with that a little bit too, probably on the in-class part of your exam. Give me your thoughts. Who are they? What's their population? What population are we studying here, folks? Good, good. A little louder.
Lower class.
Well, I saw some upper class in there too, though, didn't I? As I was scrolling through, I just happened to notice that action as I was cutting through, looking, and it kind of made me upset a little bit when I saw, hang on, this graph right here, as I was just kind of scrolling through, I noticed that they had lower class, middle class, and upper class all kind of mixed in this graph. And I think the point here is, this is a very granular look at their data. They're trying to show you that a higher percent of lower class folks put off medical care than middle class, than upper class, which in the water is also wet category of obviousness, but yes, yes. So I don't think we could break it down to just lower class folks. Be more general. Who are we studying here?
Adults 18 and older.
Adults 18 and older. We're talking about adult Americans. Adult Americans. Now the headline simply says Americans, which I never liked headlines, because headlines unfortunately distill stuff down so broadly. New record high for Americans putting off health care. Like, that's so broad, it's meaningless almost. So we're talking about adult Americans, actually. Good. Adult Americans. Very good, very good. All right. Sample size they were able to get. Who's pissed off because they can't find this?
I found
Oh, you did it. You did. Okay. Who's pissed off because they couldn't find it? Okay, raise your hands. Yes. Yes. What does Gallup do? And I don't know when they started doing this, but it pisses me off too. As you're looking through, so how many of you did Control F to look for it? Anybody do that? Control F. Let's look for the sample. You look for sample, and oh, it made a noise. Did you hear that? I didn't even hit enter. It made a noise, and boom, we can't find it. Boom. Why can't you find it? It's reported, but what did Gallup do? Scroll to the bottom. Exactly. Scroll to the bottom. Okay, here's the entire article. There's the headline. Scroll. Scroll. Oh, it's like 2 years old. I'm sorry. It's like a 2-year-old report. I'm sorry, y'all. Apologies. I have to update this thing, maybe. Scroll. 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 Lots of graphs. Lots of stuff to look at. But where do these numbers come from? Nowhere and anywhere is this indicated in the article. Until you look down here, it says survey methods. You can click that little plus sign. All of a sudden,
Actually, that's not where I went.
you didn't go there?
No.
Where'd you go?
It's a little bit above that.
A little bit above that.
There's Gallup Poll Social.
Ah! Look at you.
Oh, I see.
Oh. Does this actually talk about the one you're in, Elena?
Not exactly. I think they did the same thing for all of them.
Okay. So,
Different questions, but same like.
awesome. Totally awesome. Well, just so you know, any particular survey, Gallup started doing this like 2 or 3 years ago. I'm not sure why, but they started putting the survey methods behind a plus sign, which really frustrates me because most people are going to ignore it then. Which means they don't actually look at how, thank you, and it's tiny font size, which also drives me a little bit insane. But now, look at this. Results for this Gallup poll are based on telephone interviews conducted November 9th to December 2nd, 2022, with a random sample, I'll come back to that in a second, of, boom, we got it, 1,020 adults. 1,020 adults. We now know the sample they were able to get. 1,020. This part's not going to be down here. What was the statistic? What was the record high? Do you remember that number from the article?
38.
38%. I think it's the first percentage actually listed in the article. When you look at the very, very top, right below the headline, it says 38% say they put off treatment. The percentage of Americans reporting they or a family member postponed rose 12 points in 1 year to 38%. The highest in Gallup's 22-year trend. So you have to kind of flip-flop back and forth when you're processing these information from these reports. Okay? So dear friends, we have a statistic. The statistic is 38%. We know the sample was 1,020 people. What is the margin of error? Did you find it?
Plus or minus 4.
Right there. Plus or minus 4 percentage points. 95% confidence level, don't worry about that. We're going to come back to that. That's standard. Standard. We're going to come back and explore the meanings and limitations of that. Okay. So now we got 38%, We also have a margin of error. So should we say that 38% of Americans, should we say 38% of Americans put off medical work because of cost? Should we say exactly 38%? The only way we could say exactly 38%, they did, I'm not saying it's right, I'm saying it's wrong. The only way they could have said that is if they asked who? And interviewed who? Amelia, say it. Unless they interviewed every single American adult. That's the only way they can get away with saying 38%, if they actually checked with everyone. Can you think of a reason why they didn't do that?
Because they can't.
You physically can't. I mean, think about it. If you started asking every American adult, that's what, like 200 million people? By the time you got done, some of them will have died, and some more will have become adults in that time. I mean, it's a never-ending. It's Sisyphus pushing the rock up the hill, right? And then it rolls to the bottom and he pushes it back up. It's literally that. So you do a sample. But if you do a sample, you're probably going to be what? You're going to be off a little bit, aren't you? You're going to be wrong. So how do you adjust for that? You adjust for the margin of error. So it's the same as this. We want the percentage of, not heads, we want the percentage of Americans who put off medical care. We're never going to know the parameter. We don't know what it is in the population, but we got a statistic, did we not? So we can just adjust this for our Gallup study. Yes, let's do it. Do it back, yeah. Actually, no, do it up front, because that way you can turn around. That's stupid. You're all facing the wrong way. Go up here, Sean. I got a perfectly good board up here. See if I can do this without breaking it. There we go. Statistic. 38%, thank you, Ray. Margin of error. Turn the camera a little bit here. Margin of error. Hey, Mo. 4%. Cool. What is the confidence interval? It's a scary sounding phrase, but it literally just means take the statistic and add and subtract the margin of error. So what's it going to be?
Between 34 and 42.
You say it again, Nicole!
Between 34 and 42%.
So we are confident that between 34% and 42% of Americans put off medical care. Put off medical care in 2022. That's the correct way to interpret that 38%, just FYI. You can't say 38%, that's wrong. If you did a different sample, you probably get a different percentage. So now my question is this. Is it indeed a record high? Did you notice one of the first lines of the article said it's the highest it's been in all 22 years of Gallup's reporting on this? Did you catch that little line? It was at the very first sentence of the article. I'll go back to the top so you can see it. Right here. Rose 12 points in 1 year to 38%, the highest in Gallup's 22-year trend. What do you think, Elena?
It is.
It is. Tell me why.
They have 233, but they don't have anything that's 30.
Okay.
So maybe that was the very lowest. So
Ah! Oh! What Elena just said was, okay, so this is a little bit misleading. This graph is a little bit misleading. Because that graph, sorry about that, let me put this back over here. Is this,
That's fine.
no, I got you. That graph's a little bit misleading because that graph is graphing not confidence intervals, it's graphing just the statistics. Right? This graph, that number 38 right there, really should have some wings on it, right? It should go up and down 4% with the margin of error, correct? So really, what did we say it was? 34 to 42%, so it should look more like this, yeah? Kind of like a TIE fighter. Should look like that, right? Now, here's my question, y'all. All of these little bumps here are also statistics from previous year's reports, right? Now, they told us, didn't they tell us what last year's was, kind of? They said 38% was up 12 points from the year before, which means, what does this one have to be? 26. Got to be 26, right? If it went up 12 to 38, this is 26%, correct? But last year's, do you think they asked everybody in America last year? They probably didn't. As a matter of fact, Elaine, based on that thing you just found, they probably asked the same number of people, roughly the same number of people. Which means that that 26 probably goes up and down what? Right around 4% as well. Okay. So it probably goes up 4 and down 4. Is that fair? Now, I got a question. 26 up 4 is 30%, correct? 38 down 4 is 34%, correct? So if I may, using the little tool that I built you because I love you, 2022, 2021, 38, 26, with a margin of error of 4%. That's what those two intervals should look like, if you put them horizontal. I think it's a little bit easier to see this way. Are those intervals touching each other? That means that Gallup would be correct in saying that 2022, it appears that more Americans put off